Assalamualaikum and a very good day. My name is Muhammad Shafiq and I'm going to present my paper, which is the title of Development of Driving Fatigue Strength Index using Physiologic to quantify impairment risk levels of cognitive skills in vehicle driving. So let's start with the title description. So driving fatigue is the condition where the drivers have less time to react to oncoming hazards because their alertness and concentration is impaired. And strength index is a tool to analyze risk of particular task. Physiologic is a form of many value logic in which the truth value of variables may be any real number between 0 and 1. And the cognitive skills is the core skill that your brain uses to think, read, learn, remember, reason, and pay attention. So the introduction. Nowadays, driver distraction due to fatigue is one of the alarming issues in many countries, including Malaysia. So 80.6% of road accidents in Malaysia in year 2016 are attributed to driving fatigue. And those that having fatigue symptoms have potential for falling asleep at the wheel, misjudge speed and distance, and impair reaction time and decision making, which can result in road accident. So there are two objectives in this study. First is to determine significant cognitive skills that influence driving fatigue. And second is to develop a driving fatigue strength index to quantify and analyze the impairment risk level of three significant cognitive skills that contribute to driving fatigue, namely alertness, attention, decision making, and oxygen saturation. Next is methodology. There are three components of the methodology. First is knowledge acquisition. The purpose of this knowledge acquisition is to determine significant cognitive skills that influence driving fatigue. So to achieve this objective, I use three methods, which are literature review, pre-survey, and interview. So the significant cognitive skills that influence driving fatigue were determined by gathering information from reliable sources like previous studies, pre-survey, and interview. And there are three cognitive skills were determined, namely alertness, attention, and decision making. And another one, human factor that influence driving fatigue, which is oxygen saturation level. So table 1 shows the previous study that I used as the references. So the next component is fuzzy inference system development. So the function of this component is to develop the driving fatigue strength index for driving fatigue. This means that I use fuzzy inference system to develop the driving fatigue. So there are four components or four steps to develop fuzzy inference system. First is fuzzy logic designer. Fuzzy logic designer opened and displayed a diagram of the fuzz, which is fuzzy inference system, with the names of each input variable on the left and each output variable on the right. So figure 3 shows the fuzzy inference systems editor. So there are four input variables on the left, which are alertness, attention, decision making, and oxygen saturation, and one output variable on the right, which is driving fatigue strength index. The next step is membership function editor. The function of this interface is to define the shapes of all the membership functions associated with all the input and output variables. The input and output variables were divided into fuzzy sets defined by the membership function, and degree of membership functions was based on the risk criteria and risk levels of the cognitive skills as stated in the previous studies, as illustrated in table 2. For example, the linguistic variable of alertness was divided into two membership functions, namely fairly fit and fit, with the degree of 4 to 5 Hz and 6 to 8 Hz respectively. And for the output variable, the DFSI was divided into three membership functions, namely safety, slightly unsafe, and unsafe, with the degree of memberships of 0 to 10 Hz, 10 to 20 Hz, and 20 to 30 Hz respectively. So figure 4 and figure 5 shows the membership functions of the input variables and the output variable. The next step is rule editor, which is the function is to edit and define the behavior of the system by automatically constructing the rule statements. So to construct the rule statement, I use if-then rules, which is if A is X, then B is Y. A is input variable, X is membership functions, B is output variable, which is DFSI, and Y is the outcome, which is safe, slightly unsafe, or unsafe. So this figure 6 shows the rule editor, and let's say just now there are 30 rules that already developed, and table 2 shows the 3 examples of the 30 rules. The last step is the rule viewer, which is to view the roadmap of the whole fuzzy inference process. So the rule viewer interprets the overall fuzzy inference process and showed how the shape of particular membership functions influence the overall results, as shown in figure 7. So the first 4 columns of plots indicate the membership functions of if part, and the 5th column, which is in blue color, represented the membership functions then part. So as you can see here, this is the degree of the DFSI, and this is the plot of the DFSI degree. So for now, I already developed my driving fatigue strength index. Next is I'm going to validate my developed system by performing series of experiments to obtain data sets. So next is experimental setup to obtain data sets to validate my system. So the experiments utilizing driving simulator study were conducted to obtain samples of data sets to test and demonstrate the functioning and reliability of the developed fuzzy inference system. So in this experiment, EEG was used to examine the driver's brain activity due to its characteristics that can reflect ongoing reactions of the brain status. So emotive epoch X, which is a wireless EEG device with 14 electrodes, was used to examine participants' brain signals. The EEG categorized the signal into 4 frequencies, namely delta, theta, alpha, and beta, and each frequency contained major characteristics waveforms indicating the cognitive abilities, as shown before in the table 1 below. So this figure shows the experimental setup. So to obtain the oxygen saturation level, I used pulse oximeter. So delta means deep rest or sleep. So this frequency was ignored because it is not related to cognitive skills, since the driver is already fall asleep. And the theta which is the frequency between 4 to 8 Hz, means deeply relaxed and inward focus. That means at this stage, these characteristics visible during early state of sleep, which influence the alertness. And next is alpha, which is very relaxed, calm, and passive, which is good for attention. And beta, which is from 13 to 30 Hz, which is which is indicate problem solving or decision making. And for the saturation, oxygen saturation, the normal is 95 to 100%, and the abnormal is below the 95. So this is the sample of experimental run and the best data sets to demonstrate the fuzzy inference systems that I developed. So there are 3 data sets that I chose that I think is very good to demonstrate and validate my developed system. So this is the summary of the experimental. So the set 1, the alertness is 4.57, the response is 10.6, and decision making is 13.9, and the oxygen saturation percent of 97.7. So I will enter all this value into the developed systems that I already developed, and then I will get the DFSI degree. So this is the results and discussion. So like I said just now, on the previous experiment, I already got the data sets, or this is the summary, and then I enter all the data into this space. Once I click the enter, once I click the enter button, and then I obtained the value of DFSI degree and also the DFSI plot. Okay. So the rule viewer automatically shows the DFSI values once the input variables were entered into the system, and the DFSI value was shown on the top fifth column, this one, and displayed as a bold vertical line at the bottom of the plot, which is this one. The DFSI values for data set 1, set 2, and set 3 were 5.6x, 11.3, and 24.3 respectively. That means that my developed systems are very functioning, because once I entered the value, it produced the result of the DFSI degree. So figure 9 shows the membership function plot for output variable of set 1, set 2, and set 3. And table 6 shows the summary of results. So as mentioned before, the set 1s give 5.6x as the DFSI degree. So 5.6x is at this region, which is safe. This means that it is safe to drive. The driver is in excellent condition and need to maintain throughout driving. So the set 2, which with 4.57 alertness, 12.3 attention, decision making is 18, and oxygen saturation is 92.4%. The DFSI is 11.3. So under that condition, 11.3, it is slightly unsafe. And for the set 3, which is 4.48 alertness, 10.5 attention, 24.9 decision making, and 98.13 oxygen saturation. Once I entered the input variables, I obtained 24.3 DFSI degree, and the 24.3 is at this region, which is unsafe. That means that driver with 24.3 DFSI degree, it is unsafe to drive. The driver is in bad condition and strictly not allowed to drive, as this condition can cause road accident. So for the conclusion, the present study introduced a novel approach to minimize road accidents through the development of DFSI using physiologic, and 3 significant cognitive skills: alertness, attention, and decision making, and 1 human factor that influence driving fatigue, which is oxygen saturations, are investigated. And the developed system is tested to examine its reliability by using 3 datasets obtained by a driving simulator study, yielding 5.6x for set 1, 11.3 for set 2, and 24.3 for set 3. And this DFSI value representing safe, slightly unsafe, and unsafe respectively. And next is the results show a great capability of the developed system to provide an advance warning regarding the user's current condition through a systematic analysis. So for the recommendations for the next study, I'm going to develop a decision support system. A decision support system is an interactive computer-based information system that enables decision makers to integrate directly with computers to collect useful information from raw data, personal knowledge, and documents to determine and solve problems for structured and unstructured issues and perform decision making. So, in realizing the urgent need for solving the fatigue-related road accidents, the developed fuzzy inference system will be used for the DSSS development in the future study. Thank you.